And we're still working on, we'll get finished today, hydrostatic forces. And just like I said, the person turned up. So we did rectangles and we've done some triangles. I want to do some more triangles, but in particular, I want to do some questions from the homework, which are, how am I going to phrase this? I wish I'd written the book, because then I would have made the questions a particular way. What I'm getting at here is that the technique that I use to find the hydrostatic forces work, and there's some questions where you have to just set up the integral first before you get the answer. And about half of those, they set it up the way I would do it. And then in the others, they set it up in a different way that still gets you the right answer. But unfortunately, you won't know how to set it up because it's the other way. So what I'm going to kind of show you is a different perspective on that same process. And so I'm going to focus today on triangle questions that have set up the integral first and then you get the answer second. Right? So first one I'm going to focus on is question 12. Now in this story, you've got the water. Underneath the water, there is a right-angled triangle. It looks like this fella. And in this particular one, at least the version I've got, the height, which is that distance from there to there, is 4 feet. I'm just going to mute everyone, just because I'm getting some background sounds. Okay. So as I was saying, and darn it, I've lost the button. There we go. We got this fella is 4 feet, with a height of 4 feet, and a base is 6 feet. So although it's not to scale, it doesn't really matter. Right, that's 6 feet. And it's 2 feet off the top. Okay, so that's that part. And the delta that we're going to use, because it's all in feet, is that number. We are going to set up the integral, and then essentially you would get the answer after that. So this part, everybody does. You randomly choose a horizontal strip. And that strip is what I call the width, and I'll use W for short. And then the distance from the surface of the water to that strip, we call that guy the depth. And pretty much our goal is to find out in every single situation what the depth and the width would be in terms of x. Because once we know that, we can then get the hydrostatic force. I better not write it because I need some room, using that guy there. Now I'm just doing a quick check there, guy. In this question, try to find my color here. The distance from here to here is going to be called x. Now that's not how I would have done it. When I have picked the top of the shape to here and called that x. So that's the difference. That's the only difference actually. But that changes what each of these things are now in terms of a slightly different version of what x represents. So that's kind of where the hiccup comes from. Now that means that the depth is x, which is really nice. Now, what we have here are two similar triangles. We have a big triangle which is a 6 by 4. 6 by 4. And we have a little baby one, which is this one down here. And the little baby one is W by that number. So I need to know what that distance is in terms of X. Now, you got to kind of look at what's there and what's missing. That total distance is 6, right? If you went from here to here, 2 plus 4 more, wouldn't that total distance be 6? And this piece of it, from here to here, the one that's called the depth, isn't that X? And isn't the guy I want this piece? So what is this distance, the piece that's going to go here?
6 minus X.
Are you comfortable about how I found that missing side? Because for similar triangles, don't we need 2 from this one and 2 corresponding ones from this one? In a few minutes, I'm going to find out what W is, the width, and I'm going to write it in here, and that's pretty much the end of this question as far as I'm concerned. So 4 matching with this guy is going to equal 6 matching with this guy, right? Corresponding sides in equal ratio. Now, if you do a little cross multiply, 4W is 36, take away 6X. Right, going this way. Dividing everybody by 4. Why is my answer looking different? 4 is good. 6 minus 6. Yep. With, I'm going to try muting again. See, maybe getting some clicking sounds. Gotcha. Hopefully. I'm just a little bit, I just want to double check because something doesn't look right. Maybe it's just, it's right and it doesn't. Is that definitely 6? Yeah, well, that's what. Cool. 6, take a X. Yeah, okay. I just have to trust the math. Somehow it just didn't look right. Which means the width then has just been found. Is that okay? So the hydrostatic force is going to be the integral from some guy called A to B of delta, the width, followed by the depth, the X. Now delta, I guess it's delta, I'm not going to turn into a number. The width is 9 take away 3 upon 2x, and the depth is x dx. Right, now A and B always represent the same thing. A is the value of x that gets you the top of the shape, and B is going to be the value of x that gets you the bottom. Now notice the x is this thing. So won't A be that depth, which is 2, and won't B be this depth, which is 6? Are you comfortable how I got those two numbers? That if you're going to use x as the depth, then won't A be a depth of 2 and B be a depth of 2 add 4, 6, so 2 to 6. And that's the guy that you fill in the box with. Now, if you did it the way I did it, which is you'd make this distance x, you would get a different equation and different start and finish values. But the two integrals would both end up being exactly the same answer. So it's not like it's a different method and you get a different answer. It's the same answer, just a different method to get to there. Now, I can see that method as being quite valid. What this method does that's nice is, doesn't it make the depth dead easy? but doesn't it make this bit a little bit clunky? If you do it the other way, the depth is a little bit weird, but it's not that bad. So I prefer my way, but that's me. In an exam situation, if you're only looking for the number, then any method you like will work, right? You can pick any technique you like as long as it's valid. I'll leave that for a few seconds. Is there any questions about this one that we've just done? So are you comfortable that you can make the strip at the depth of X if you want to go that method? Or you can make this X, and that means the depth becomes what X add 2. Right? So you either make one of them easy and the other hard, or you make the other one easy and the first one hard, right? Whatever way around you want to do it, one of them's going to be ugly. Oh, yeah. Okay. Just going down and see if I can find another one of those build the integrals. Didn't take me long. Question 13. Here's the waterline. Here is a triangle. This particular triangular plate has a base of 3 and a height of 5. So that guy there is going to be 5 meters. And this distance going this way is going to be 3 meters. And since it's on the surface, I don't have any depth. Delta then is going to be 9,800. And we're being asked to set up the integral, and then you get the integration part. I'm again just going to do the setup part, and you can do the, integrate using the power rule layer. So, typical strip. There you go. It's going to be the width. It's going to be W. The distance from the surface to there is called the depth. Are we cool with that being the depth? And I'm also going to make that X, because isn't that the distance from the top of the shape? So in this question, they're going to use my method. I'll call it my method, but it's not belong to me, but the method I use, right? So do you see how the previous one, they made the depth X all the time, and then they figure out what to make the other one. And I like to take the top of the shape to the strip and make that X. But in the case where they are on the surface, isn't it going to be the same thing for both of us? So we are already getting this thing set up. We have a depth and we have a width. And the depth was X. Now I have got a little baby triangle, which is W by X, and I've got the big 5 by 3 guy. So X over 5 is W over 3. So 5W will be 3X. So W will be 3/5 X. Quite a nice one, right? Not actually that ugly at all. So the hydrostatic is from A to B. Width, depth, dx, a little delta in there. In this case, they stuck the delta outside because they wanted to, I guess. The width is 3/5 X, and the other guy is X. Huh. You know, they didn't even multiply that together and call it 3/5 X squared. Go figure. I need a start and a finish. Well, in this case, the top of the shape will have an X of 0. And when you get to the bottom of the shape, won't the X have a value of 5? And that would be our integral. And can you imagine doing the power rule and plugging in 5 and 0 and then multiplying everything by 9,800 and getting an answer which I think is about 250,000. So that guy is what you fill in the box at the beginning, right? And then whatever the number is, that's the answer that you do afterwards. There we go. Okay. Let's go looking for another one. I don't think there's much more. Oh yeah, here we go. 15. This question looks like many of the others, but it's not actually the same. Normally, don't we use similar triangles? Right. And the answer is yes. And will this use them? And the answer is yes. But this is going to involve some extra work that you don't typically need to do with triangles. Because normally when you do triangles, don't they tell you the height? They are not. They are telling you the sides. And that means we're going to have to tweak it a little bit. Maybe not more than a little bit. In this question, it's an equilateral triangle. And they're all 4 meters. I'm going to put my strip in. That's going to be my width. It's going to be W. And the distance from the surface to that strip, that's going to be my depth. And my depth is a vertical distance, and it's going to be called X. This question, all the hard work is going to be in finding that width, because that is not going to be anywhere near as nice as you would hope. So I'm going to redraw this triangle because there's too much going on. And I'm going to just put 4 here. I guess I'll do it in red. I'm going to split this triangle vertically. Okay. And then I'm going to put in my strip. But I'm only going to concentrate on the length of this piece. Now, can you imagine if you split this shape in half, won't this piece be a half W? You agree? You split an isosceles and an equilateral triangle vertically down the center, you cut it into 2 equal pieces. And not only do I cut it into 2 equal pieces, aren't these 2 pieces both right angle triangles? And isn't this side 2 and that side 2? Still with me? Now, this right-hand side piece, I'm going to separate it out. And the reason I'm doing that is so I can tell you where the vertical line from there to there is, why that became root 12. Does anybody know where that number root 12 that I pulled out of there came from?
If you have your unit circle measured, that's pi over 3, and the sine of pi over 3 is square root of 3 over 2. And if you multiply that by, so your hypotenuse on that triangle is 1, you multiply it by 4, you end up with the square root of 12.
Yes. Oh, and I think you were going to tell us a different way of doing the same thing, which is perfectly correct, and you're right, Megan. That's correct. But there's another way to do it as well, isn't there?
Pythagorean theorem.
Pythagoras as well. And Pythagoras is 16 take away 4, root 12. Right. I like different ways of doing things. See that? There's two different ways of finding that guy. Right. So, back to this picture then. Can I just write the square root of 12 there now, and you know where this distance that's now became blue came from? And can I now go over to this picture? Oh, my pen's just died on me. This picture. And put that guy in. And this is the triangle that I'm going to use to do my similar triangles with. So I've got a little baby triangle. Oh, almost forgot. Remember, this distance here is x. Isn't this distance from here to here x? Right. So from here to here is x. That distance is root 12. I need to know what this distance is. Root 12, and this bit is x. So what's this bit? Because I need to know.
Root 12 minus x.
Yeah. So very badly drawn triangles. Root 12 take away x and a half w. And this fella is just a root 12 and a 2. Oh, I think I can squeeze it in here. So root 12 take away x over root 12 is equal to 1/2 w over 2. If you cross multiply, you get this guy, and it's equal to that guy. I'm going to do this in 2 steps because it's messy. I'm going to multiply everybody by 2. And then I'm going to divide everybody by root 12. Do you see, I now have found out what w is. And I wish I could tell you that that's the numbers that they use when you build the integral, but it's not. Because 4 over root 12 can be simplified. Not much, but a little. And not only that, they didn't even simplify it the way I would have done it. If they were going to simplify it, I would have done it differently. But let me show you how they did it so that you get the answer to match what they're looking for. They take the root 12. Does anybody know what square root of 12 simplifies down to?
2 square roots of 3.
We all happy with that? 4 times 3 gets you 2 root 3. And then they cancelled and they got that. Okay? And that's the answer that you're going to be using for your W. It's going to be 4 take away 2 over root 3x. If you were going to simplify it, I think you should just keep going then. If you're going to do that, do it right. Would you agree that's probably not the best way to write that fraction? So if you multiply the top and bottom by root 3, you get 2 root 3 over 3, and that's what I would have used. But that's not what they used, so I'm going to have to stop at where they stopped, right? So it's 2 over root 3x. So our integral is from a to b, delta, width, multiplied by depth, dx. And it's from the top of the shape, which is 0, to the bottom of the shape. Oh, what number goes here then? What's the value of x when you get to the end of this triangle?
Root 12.
Yeah. So even that was a little bit clunky. And the width is 4 take away that fella x, the depth is x dx. And that is what they're expecting you to do in the integral part. If you see two little, looks like wavy lines, looks like the Olympic symbol, what does that mean in mathematics?
About?
About. So you know that you could do this calculation with 9,800 and some really ugly square roots and do it exact, and you could, I guess, tell me the answer exactly. But if they say that and then they tell you to the nearest whole number, couldn't you just basically do it in your calculator and round it off to the nearest whole number and save a whole load of work? So whenever you see a little squiggly line approximately equal to, you can take your integral. You'll have to remember to turn that into 9,800, but you can do that on your calculator. Does anybody need me to show you that on the calculator in case I've forgotten how to make it happen? Anybody want me to do that?
If you could, that would be great.
I will do that. Right. Now, I'm going to use my emulator guy. And if you hang in there for a minute. Here we go. Right. So hopefully you're looking at a big version of the TI-84. Right. It's a little bit easier than me showing it on that footy wee screen. Now, there are two ways to do this, and I'm going to show you both. And since this video will be recorded, you don't need to frantically write down the instructions, but you can go. And then you can decide which of the two methods you like, because some people like one more than the other, and that is fine. So method number one is you hit y equals, and you type in the whole thing. So delta is 9,800, and then I had an x, and then in brackets, I had 4 take away, well, it's 2 root 3 over x. I have to be really careful about this. I like to work on the side of safety. There. I've basically put the 2 root 3 inside a bracket. And the reason I'm doing that, I'm worried that the calculator might think it's a 2 on the top and a square root of 3x on the bottom. And it's sometimes kind of hard to make the calculator do what you think you're writing may not be what it thinks you want. And so I just stick brackets around it. Now, I'm not saying it needed them there, but it's better safe than sorry. And then I go to Window, and I type in 0, and I do square root of 12. Oh, let's try that again. I got the wrong button. Square root of 12. I do zoom 0. You'll basically see a nondescript curve. That's more interesting than some. And then you do second calc and choose number 7. And it says, where do you want to start? So you say 0, that's the lower limit. It says, where do you want to finish? Square root of 12. And then you hit enter. Okay, darn it, what did I do wrong? Nothing, obviously. Okay. Lower limit, 0. That was good. Upper limit, square root. I wonder if it doesn't like the square root of 12. It doesn't like the square root of 12. That is weird. Okay, I can do a workaround. Somebody who's got a calculator handy.
3.46.
Hold that thought. So there to 3.46. What a weird idiosyncrasy. Okay, so the answer is approximately 78,400, which actually is the correct answer if you round it off to nearest whole number.
Yeah, when I did it in the calculator with a square root of 12, it's exactly 7,840.
Oh, so you got square root of 12 and I couldn't.
I used Desmos.
Isn't that just a mystery of the world that we'll never solve? Because you know I'll do this question tomorrow and the square root of 12 will be perfect and it'll like it and it'll get the answer. Okay, now, clear this guy out the way. I said there's 2 ways to do this. That was version 1. And now you're going to get version 2. Now, version 2 has one big advantage. It's much quicker. It has one big disadvantage. It's much clunkier. It's less intuitive. So I hope I don't screw up. You do math, and I believe it's number 0, choice 0. Oh, I take it back. It's choice 9. You find a guy called function integrate, FN int, and you hit enter. And you type in your function, 9,800, x, bracket, 4, take away, I'm playing safe again, 2 divided by the square root of 3x, close brackets, comma, x, comma, 0, comma, square root of 12. So the format is the function that you're trying to integrate, right? So suppose it was x cubed. So you do x cubed, comma, pretty dumb, you tell it x. You'd think it would know it because of the x cubed at the start, but it doesn't. So function, comma, x, comma, a, comma, b. A would be the start number, in this case 0, b would be the finish number. Now, fingers crossed, and let's hope that it doesn't have a problem with the square root of 12, and the answer should be 78,400. Now, if you feel comfortable with that, that's actually kind of how I do it. If I'm personally doing integrals and I just want to know a numerical answer, I just use this. It's a little bit clunky because you have to make sure that you put in the comma x and all that nonsense. And it can be a little bit weird, this bit, but that's true in the other method anyway. You know, you need to have brackets inside brackets to make it work right. We like that guy? So I'm guessing you've probably already made up your mind which method you want to use. I don't need to know it because both are correct and both are usable. And so you use them. Any questions so far? Are we good?
Is using Desmos okay for that?
Yeah. Since it's just asking you for a numerical answer, if you can use Desmos to do it, it's fine. I'm not going to show people how to do that. What's that?
It's super intuitive. It's easy.
Okay, so you could probably go and find out yourself, right? Okay, nothing wrong with that. Anything that's numerical, pretty much whatever method you use is fine. The next one that involves an integral is question 16. And then I'm looking at my time here. 16 basically has a triangle that's submerged under the water at 6 meters. And this guy here is 2 meters. And this guy here, at least in my version, is 6 meters. And they put the strip here. And they make this distance X. And that makes this distance the depth. And that's X add 6. So in other words, do it the way I do it. So question 16 is you set it up the way I set it up and you'll be fine. That gives us what time we have got left now to do the only other shape that we haven't tackled. And that is bits of circles underwater. And this does not use similar triangles. It's the only, well, apart from rectangles, it's the only one that doesn't, right? Now, in this particular version, the distance under the surface is 1 foot, at least in my question. So that makes delta 62.5. And the diameter of this circle you are given, and it's 10 feet. And we have to set up an integral and then get the answer, but it's nice squiggly line answer, which means you can get the numerical answers from your calculator. So really the hard part is going to be the setting of this up. Now, I'm going to approach it the way I do all the others. So that distance there is going to be called the depth. And this is where things get really different. First thing the book does, which I would never do, is that they decided that it's now going to be called Y instead of X. I don't know why they decided it was Y. I don't mind why, but just make all of them Y. I can understand why, right? It's vertical. Kind of Y makes sense, it's vertical. But if you're going to do that, shouldn't you just make every question Y? Right? But they didn't. They decided only to do it with circles. That's the first difference. The second difference is that this guy here, from the bottom of the plate to this slope, is Y. Now, if I was doing this question, I would also have done that. I would have just called it X. So that's really only cosmetic. So let's figure out what the depth is, which is this red line from here to here. Well, you've got to figure out that there's some things that you need to know before you commit yourself to an answer. What's the distance from the top of that circle to here?
5 feet.
Agreed. The diameter might be 10, but isn't that only 5? Now, I would like to know the depth. And the depth is a little bit tricky. If I tell you that the total distance from the surface to the straight line is now 6 feet, and I tell you that this little piece from here to here is called Y, isn't the depth that piece, right? So now that I've kind of constructed it that way, what is the depth in terms of Y?
X minus Y.
Do we agree on that, guys? This picture is going to get much uglier in a few seconds. So I'm going to draw the extra lines, and then I'm going to separate it out after that. You cut the circle into halves by that vertical line. You then add another line from the center to there. And when you do that, you make a little baby right angle triangle. I don't want to shade it, and I'll shade it in green. Can you see a little baby right angle triangle? Now, the distance from here to here, would you agree that's only a half of a W? So I'm going to suck out that little triangle, make it a little bit bigger. Now that's the blown up version. That is why that is a half W. What's that distance there? The hypotenuse.
Five.
You want to tell the others why it's 5? Because it is.
Because it's the radius of the circle.
Yep. That's it. Because it's the radius of the circle. Now, do you notice that we have got a right angle triangle where we know what the 3 sides are in terms of at least a variable? So I'm not going to use similar triangles. I am going to use Pythagoras. And Pythagoras is going to allow me to find out what W is in terms of y. Now, according to Pythagoras then, shouldn't 5 squared be y squared plus a half W squared? So 25 should be y squared plus 1/4 W squared. So far, so good? Now, how about subtracting a y squared from both sides? Remember, my goal here is to get W, right? To solve for W. So what should I do to both sides to get a bit closer?
Multiply by 4.
Now, I'm going to write that down as a multiplication rather than 100 to take away 4y squared. And there is going to be a reason for that. That should come out really almost immediately. What do I now do to both sides to find W?
Take the square root.
Square root both sides.
I hear that. Square root of both sides. Bang on. Now, do you see by calling it 4 times that, can't I suck it out as 2 times the square root of this guy? Just a little bit prettier version of the answer. That's the only essential difference. So the total hydrostatic force is going to be the integral from A to B. And I'm missing my job here. That's the depth. And we just found out what the width was. So all this. So it's going to be A to B, delta. Well, too late now. Depth times width, dy. Delta is, well, I'll just leave it here for the minute. The depth was this fella. And the width was this fella. If I put the 2 and the delta together and then suck it outside, what we're left with is 6 take away y, a square root of 25 minus y squared, and a dy. Oh, and I haven't put the start and finish of the y values. Now, where do you start and where do you finish? Well, you start at 0, I guess. And where do you finish? At 5. Would you agree? Y equals 0 to y equals 5. Of course, squiggly lines, because you can use your calculator to get the answer as a number. You agree that one's a little bit messier than any of the others. It doesn't use similar triangles. It uses Pythagoras. And it doesn't measure the X or the Y, whatever letter of the alphabet you decide to use, in the top-down approach. It's a bottom-up approach. And that's typically a good idea for anything that's circular, to do the bottom-up approach rather than the top-down approach. If you try to do it the other way, can you trust me that this equation gets really, really ugly? I mean, it just does. It's bad enough, but it would be twice as bad if we tried another way. Theoretically, of course, it would still be correct, wouldn't it? Can't you measure from the top or the bottom? Can't you measure the depth to be Y or X? Or the top of the circle to there as being X, or any other combination you like? The answer will still be the same number when you're finished, but just some of them are a lot more work than you want to do, algebraically at least. And that is perfect timing. I'm getting